our last class, what we did was to prove that the first of the properties of the chart, right, where we found an E, right, that was that if you have a consistent mean value, then it has to be exponential, right? For today's session, we will work with premium reduction by coinsurance, okay? So I will present just a little introduction, and then I will prove a little theorem, okay? So when we co-insure a risk, what that means is that, well, we are going to share the risk. In this case, this is the risk, right? And we will share it with another entity. Now, the most regular of these expressions is precisely the expression of, paying for one proportion of the risk by yourselves, right? And just leave another proportion to another entity. The most common, as I was saying, is just to take the insurance company as that entity. Now, what we suppose is that we consider n insurance companies, right? And we also suppose that they all have exponential utility functions. So recall that, as I told you before, the most common of all utility functions is precisely the exponential one, because it just rises in many contexts, right? Now, each of these insurance companies, right, has their own parameter alpha, right? So the risk that all the companies are facing is precisely given by this amount here. So what we see in this drawing has even more of a sense, because these guys here represent an insurance company. Each one of them is an insurance company, and they all together, right, can add up to be able to face a huge risk. So as you can see, one of these guys will not mean a real threat to this other guy here. However, all of them together represent an even bigger shark, right? So this SI here denotes the risk that the I insurer is facing by himself or by itself. Okay, so now we readily know that should you have an exponential utility function, then additivity applies, right? So the total premium that all these companies need is given by this sum here. So the question that we will be addressing during this session is this one. How should the insurers split up the risk S in order to make the pool as competitive as possible? And in here, we have a word that might be misleading, because what does it mean to be competitive, right? Well, competitive means to be, for instance, inside the market, right? And also to be able to compete with the other insurers, okay? Now, the point here is to try to minimize the total premium. And why would you want to minimize a premium? Well, the reason for that is that you should be aware of your social responsibility. Now, this result is the main of this section. The optimal choice for the problem at hand is when each of the insurers insures only this amount here. Now, please observe that in this case, I am not using the original random variable s sub I, but I am using s tilde sub I, right? And each one of these is going to be given by this thing here, okay? Now, the alpha is going to be given by this sum of, by this harmonic sum, okay? Now, the corresponding total minimum premium is given by this other sum here, which is actually really obvious because we just saw that, okay? Now, the point here is, really? Does this thing here equal this total premium under the exponential utility? Well, that's the point of this result. Because, I mean, this is just obvious because we just said that. But the fact that this equals this other sum here, well, I'd say it's rather surprising, okay? So this result states that the optimal allocation is to let each insurer cover a fraction of the pool risk that is proportional to the reciprocal of its risk aversion, okay? The reciprocal of its risk aversion. So this means that the group acts as only one insurer with an exponential premium principle, right? with as much tolerance risk as the total risk tolerance of the companies involved. Now, I was saying that the first equality, that is this thing here, it says the second one, but I'd say that this one is the one that is more or less straightforward. So as you can see, since each of the insurers is supposed to have an exponential utility function, right? Then the premium at hand would be just an exponential premium, which is just given by, say that we take only this, right? Without the sigma here, right? So the regular P for, say, the I insurance company would be given by this. However, the P that we're looking for will be given by the same thing, but with a proportional part of the risk that is S tilde, right? Given by this expression here. So as you can see, this risk here is the risk that conglomerate of all the insurers is facing. But the risk that the ith insurer is going to face by itself will be given by this expression, which is just a proportion of the whole risk. So the first part that the result says, the first part of the proof is that it's supposed to be straightforward, that this thing here equals this thing here. But you know, I don't see it. So why don't we do this? Why don't you try to prove that part by yourselves, right? And see what happens, okay? Then we will see that the premium is actually minimum. So the first part is to prove that this sum here equals this part here. It should be clear because the definition of this alpha I. So you just need to put, instead of S tilde, this S here, right? So the first part is rather surprising. However, it is direct. Now, the proof that this P tilde is actually minimum follows from Hölder's inequality. Now, this is one of the most common expressions in all of mathematical analysis. Just so you can have a quick reference on it, I will write here Hölder's inequality there, okay? So, desigualdad de Hölder, there you go. So this is Hölder's inequality. It says that you can take the norm in L1, this is the norm on L1, of the product of f times g, when f and g are functions in LP and LQ respectively. And then that thing is supposed to be lower or equal than product of the norms in P and in Q of f and g respectively. And that's it. Now, if you change the P and the Q for 2's, then what you have is super known inequality of Cauchy-Bunyakovsky-Schwarz. Fun fact about this inequality here is that, well, it depends on the country where you're studying this thing here, the inequality of Cauchy-Bunyakovsky-Schwarz. The fact that it is called inequality of Cauchy, inequality of Bunyakovsky, or inequality of Schwarz. Because, for instance, in Russia, that inequality is known as Bunyakovsky's inequality. In France, it is just known as inequality of Cauchy's inequality. Actually, maybe you know it precisely with that name, because here in Mexico, the syllabus just follows the French syllabus. And in the German-speaking countries, well, they just call it Schwarz inequality, right? So, as you can see, all we have to do is to write the P, right, that we just defined. And then we just drag our pencils a little bit, right, to change this expectation by this other expectation. So in here, all I'm doing is that I am changing the full risk S for its definition, right? And then I just take this sigma out of the exponential, right? By using a product, right? And then what I do is that I take the product out of the expectation, right? but then I have to use Hölder's inequality. Please observe the fact that I have also chose to use the alpha i's, which is absolutely, it doesn't mean a thing because all I'm doing is that I'm taking the p and the q's that I've just shown, right? So I can do this. And now I can just use the properties of logarithm to take this product out of the logarithm and transform it into a sigma, so that what I have is that for all values of the alpha, right, you can have that this p tilde is lower or equal than the p, which was precisely what we wanted to prove. Now, please observe also that this premium also tells us it is best for the policyholder to just pay that amount instead of this other amount here, because this thing here is lower or equal than this other thing over here, right? So maybe you've heard in your first encounters with this discipline that the best thing you can do when buying insurance is to actually go for a co-insurance with the company. So it depends, of course, on this coefficient of aversion, right? And this result tells us how to do that. Okay, so that's it, guys. And well, that's the presentation for today. And here are the references.